Hi there everyone and welcome back to NCE. In today's video we're looking at question number 6 right from May-June 2019, and this is a trigonometry question, right? So really the focus of the student's question is for us to please look at question 6.2.3 right from this specific question, but we'll just run through the entire question 6 anyway. Okay. We'll start off with question 6.2.3, right, because it really is just separate from the graph. Right, so if we look at question 6.2.3, right, we asked to determine the range, right, of this function, okay? Y is equals to 2 to the exponent of 2 sine x plus 3. Okay, all right, so if we had to really decode this question, right, this would be a higher level question, okay? And it's a higher level question because it's unfamiliar and the way to solve it, right, is not necessarily clear, right? So there's no clear method that we can say, this is what we're going to do from here, okay? So really with higher level questions, what you have to do is to combine all the knowledge that you have accumulated so far. Right. So really with this question, just break it into components. Okay. First, think about or recognize the structure, right, of this function. Okay. It looks very similar to just an exponential function, right? Y is equals to 2 to some exponent. Okay. This little box, right, is representing, okay, if we think about this, an input. Okay. We could make this similar to the function y is equals to 2 to the x. Okay, we know that x is a input, right? It's nothing but just a input. Okay, so what has happened if we compare it to what we have to look at, right? Our input has become a little bit more complicated. Okay, it has become a function as well, right? 2 sine x plus 3. Okay, and that is a trigonometric function. Okay, so why am I actually pointing all of this out? Well, it's just a sort of like a thought process that you can use, right, to try and help you to get to the answer. Okay, so if you first of all still think about this function y is equals to 2 to the x, right, you can remind yourself that that function is an exponential function, right, that if you had to graph it, it would basically just look like this. Okay, it would be increasing like that, right? We know that that point, okay, would be a point 1, okay? So this would be 2 to the x, right? But this, right, function is increasing, right, because the input is simply just an x, right? So now recognize the fact that the input now, right, what we've put into this box is not just an x, right? We've now inputted 2 sine x plus 3. Right, now if you think about this function itself, right, we know that this function, okay, is obviously going to go up and down, right, because that's what a sine function does. Okay, and because this function, right, basically has limits, right, it means that it's not going to allow the overall function, right, this complete function, right, to act in the same way as 2 to the x, right, to just go all the way exponentially like that, right. It obviously then is going to cause it, right, to be trapped sort of in between two y values. Okay, so which means that if we can figure out what is the range, okay, so if we can figure out what is the range, right, of this function, okay, and then take that range and put it back into this complete function, okay, then we can determine the range of the original function y is equals to 2 to the exponent 2 sine x plus 3. Okay, right, so now let's go back over here. Okay, let's talk about this function. Okay, all right, so if we put sort of like a general form on top of this, right, we know that in general form we'll have a, right, sine of b into x plus c plus d. Okay, remember that a is the amplitude, b determines your period, c is a horizontal shift, and d is a vertical shift. Okay, so what do we have over here? Right, let's draw ourselves an axis. Right, let's first draw the function sine of x. Right, so the function sine of x, we all know, looks like this. Okay, it has a range, right, from -1 to 1. Okay, so this is sine of x. But we are not looking at the sine of x, right? We're looking at 2 sine plus 3, right? So let's first take this first part, okay? The 2 sine of x, right? We know that 2 sine of x just tells us that what's happened now is that instead of having an amplitude of 1, we now have an amplitude of 2. So that's the first part, right? Do we have a horizontal shift over here? No, we have nothing, okay? But we do have a d value, okay? We do have a d value, okay? So this function, this one, okay, in red, which is 2 sine of x, right? That's now been shifted 3 units upwards, okay? Right? And we use them to basically shift the red graph 3 units upwards. Right, let's start off with this one. If we are at a y value of 0, if we move 3 units upwards, it will get to 3. Right, this one is at a y value of 2. Okay, so 3 units upwards, 1, 2, 3 will put you at a y value of 5. Okay, the next one goes up to 3. This one is at -2, so 3 units upwards. 1, 2, 3 will go up to 1. And 0 will go up to 3. Okay, now this line, right, basically the x-axis, right, that is y is equals to 0, right, so that will go up to 3 as well. Okay, so basically the line y is equals to 3 is now acting as if it was our imaginary x-axis. Okay, so if we are to connect this graph, we know that we'd go upwards, come back down and have an x-intercept in inverted commas, and then back up again. Okay, so this graph in green, this is y is equals to 2 sine of x plus 3. Okay, so now that we have that sketched out, okay, we can now see that the range of this function, okay, is basically all of the y values, right, from a y value of 1 up until a maximum y value of 5. Okay, so there we go. We've now achieved to do one thing, right, which is to determine the range, okay, of this upper function, right, so this input function, okay. Now, notice that this basically has a minimum value, okay, so the lowest y value that it can attain, and it has a maximum value, okay, so the highest y value that it can attain, right. Okay, right. So now going back to this original function, okay, going back to this function, right, we noted the fact that even though it has an exponential form, right, it's not going to act like an exponential function and just go off to infinity like that, right? And that's because its inputs, right, have a maximum and a minimum value, right? So because of that, okay, it means that this function, right, its range is also going to be tracked, right, by these two maximum and minimums, right? So now if we go back to what we said in the beginning, right, and we noted the fact that basically what's happening here is that you have y is equals to 2 to some input, okay? So we've now determined the maximum and the minimum input, right? So if we take these two, right, values back in here, they basically become x values, right? That will then help us to determine the range, okay, of y is equals to 2 to the exponent 2 sine x plus 3, okay? So we're going to first say, right, the first thing we need to do is to figure out what is the minimum, right, y value that y is equals to 2 to the exponent 2 sine x plus 3 is going to have, right? Well, that is going to happen when we actually have a minimum input, right? So that's going to be 2 to the exponent of 1, okay, which is equals to 2. And then what is going to be the maximum y value of y is equals to 2 to the exponent 2 sine x plus 3. That will happen when the input is a maximum. It's going to be a maximum of 5, right? And this is 32. Okay, right. So then, similar to this, right, we can then say, therefore, right, the range of y is equals to 2 to the 2 sine x plus 3, right? If we write it in interval notation, right, it's going to be is y is an element, okay, it's going to go from its minimum value of 2 to its maximum value of 32. Okay. Right, so now let's look at the other questions, right, from question number 6. Let's go for question 6.1. Okay. Right, so question 6.1 is a general solution, okay? So I just want to give you a little bit of tips, right? When you're looking at general solutions, right, you just need to be aware of the types of general solutions that we can have. Okay, so we basically have two types, right? We have the types where your angles are different, okay? And we also have the type where your angles are the same or equal, right? So angles are the same. Okay, so if your angles are different, there's two situations that can occur, right? It's either you are going to have no coefficients, right, in front of your trig ratio, right? In other words, you're not going to have an a value, okay? Or you are going to have an a value, right? And you're going to have a coefficient, okay? If you don't have a coefficient, right, the strategy is to use, right, co-functions or co-ratios, okay, which is your 90 degrees minus theta, right, to solve the general solution, okay? And usually we say that you should just change any trig ratios into sine, right, into cos, sorry, right? So if you have sine, just change it into cos, okay? If you do have coefficients, right, then our strategy is just to expand out, right? And you understand what we mean by expand. basically we're going to be expanding out a compound angle, right? So we have to expand the compound angle to solve. Okay, so if I can give you an example of this first case, right, where your angles are different, right, and we can use co-ratios to solve something like, maybe let's say the sine of x plus 30 degrees minus the cos of 2x is equals to 0, right? So if you can see over here, right, your angles are different. You've got x plus 30 degrees and you've got 2x, right? And you have no a values, right? Because you can see that this can basically be written as sine x plus 30 degrees is equals to the cosine of 2x, right? So because you have that set up, right, what you would do is that you would change the sine of x plus 30 degrees into cos, right, using 90 degrees minus theta, and then solve from there. Okay. An example of the second case, right, where your angles are different, right, but you have coefficients is exactly this case that we have over here, right? So cos of x minus 30 degrees is equals to 2 sine of x, right? Again, you can see that your angles are different, right? But this time, one of your functions has a coefficient, right? Or it has a value. Okay, so this is a sine of x. Okay, so we'll get to solving this, but basically we now know that the strategy that we're going to use is that we need to expand out this compound angle. Okay. Right, so on the other side, okay, sometimes you can have general solutions where the angles are the same, right? For this one, we also have two cases, right? We're not going to have the case where we're going to be looking at no coefficients, right? We're always going to have coefficients when we're looking at angles that are the same, okay? But in the second part, right, not only are you going to have coefficients in front of your trig ratios, but you're going to have this, right, equal to a number, right? So equal to some number. Okay, right. So what do you do if your angles are the same and you have coefficients? This is the one that is the most easiest to solve, right? We just divide through by cos. Okay, so what is an example of that? Well, something like 6 sine of x is equals to cosine of x. Okay, what do we see over here? We see that the angles are the same, right? We've got an angle x and x, right? And we also have a coefficient on one of these trig ratios, right? So the approach here is simply just going to be to divide through, right, by the cosine of x, right? And you can see that the reason why we divide through by the cosine of x is because this side then changes into 6 tan of x, and this will equal 1, right? Remember that when you divide two things that are the same, it's not going to equal 0, it actually equals 1, okay? Then from there you have the tan of x is equals to 1 over 6, right? And you can solve from here, okay? Right, so what is an example of this last case, right, where you have angles that are the same, you have a coefficient, and all of this is equals to some number, right? Then it is something like this, okay? So the cos of x plus root 3 sine of x is equals to 1, okay? So what do we do over here? Well, the strategy in general is to divide through by 2. Okay? I don't think they're going to give you any other case where you don't have to divide through by 2, right? But I do have an example on the channel where we had to figure out what to divide by, okay? Because sometimes it is not 2, right? But in your case, I'm pretty sure you can just take this case where you're always going to have to divide through by 2, right? I don't think they're going to put you into that situation where you have to divide through by any other number, okay? So what happens with this case? Basically, what happens with this case is that you actually create a compound angle, okay? So let's look over here, right? So if we analyze, right, you see, okay, your angles are the same, right? You have some coefficient on one of these trig ratios, and the important thing is that you have this extra bit over here, right, where you have this equals to some number, okay? Right, so let's do that step of dividing through by 2. Okay, and then what we're going to do is that we're going to be a little bit smart here, and we're going to rewrite this as separate terms, right? So recognize that there's a 1 over here, right? So you can rewrite this as 1/2 cos of x plus root 3 over 2 sine of x is equals to 1/2 now, okay? And now what's happened is that you've actually formed the values, okay, the exact values of special angles, okay? And the tip that you can really just pull up from here is to look at the structure, right? You've got cos and then sine over here, right? So this should be the compound expansion of sine, okay? So basically, if you think of 30 degrees, right? Because if this is going to be the compound expansion of sine, right, it has to start with sine, right? So you can guess 30 degrees, right? 30 degrees has the coordinates root 3 over 2, 1/2, okay? So the 1/2 is basically the sine of 30 degrees, right? Then you still have the cosine of x plus root 3 over 2 is basically the cosine of 30 degrees, and then you still have the sine of x. This is all equals to 1/2, okay? So now you can see you've got you have sine, cos, cosine, right, which is the compound angle expansion of sine, right? So this can collapse down into the sine of the first angle, which is 30 degrees, plus the second angle, which is x, and that will equal 1/2, right? So you've now reduced this down into one trig ratio, and you can solve from there, right, getting your reference angle and all of that, okay? Okay, so if we go back to our question, right, we had the cosine of x minus 30 degrees. We want to know when is this equal to the 2 sine of x. Okay, so we already identified that what we have here is different angles, right? And we have coefficients, so we have to expand out this compound angle over here, right? So if we expand this out, we'll have the cos, right, of the first angle, which is x, times the cos of the second angle, which is 30 degrees. The sine will change, right, and then we'll have the sine of the first angle times the sine of the second angle, right, and all of this will equal to sine of x, okay? So we have special angles in here, right? We have the cos of 30 degrees and the sine of 30 degrees, right? We've already looked at the coordinates of these two, right? So the cos of 30 degrees we already saw is root 3 over 2. And this is going to be times the cos of x, right? And the sine of 30 degrees is 1/2 times the sine of x, okay? Now notice that what we have here is a half sine of x, right? We can subtract from that 2 sines of x and set all of this equal to 0, okay? Right, so simplifying, we have root 3 over 2 cosine of x, right? So you have a half, right? And then you take away 2, right? which means that you now are left with negative 1.5, right, or negative 3/2, okay, sines of x, and this is equals to 0. Okay, so now we've moved, right, this original general solution, into a different type. Okay, we now have the type where we actually now have the same angles, right, and we have some coefficients. Okay, and we don't actually have this equal to a number, right, we have this equal to 0, right, so which means that it's nice because we don't have to worry about dividing through by anything. What we can do is to just set these two things equals to each other. Okay, so we're going to have root 3/2 cos of x is equals to 3/2 sine of x, right? So then from there, we can now use the strategy of a general solution where you have the same angles, right, and some coefficients, and we're just going to divide both sides by the cos of x. Okay, so this then leaves us with root 3/2. It's going to be equals to 3/2 tan of x. Okay, right, so simplifying from here, right, we just need to divide both sides by 3/2, okay, which is basically going to be the same as multiplying both sides by 2/3, okay, so which is going to give us root, what is this, 2/3, so it's going to be root 3/3, okay, is going to equal the tan of x, right? So we now have the tan of x equal to a positive number, right? So let's draw up our cos diagram. Okay, we basically know that tan is positive in the first quadrant and in the third quadrant, right? So then that means that we're going to have a solution in the first quadrant and a solution in the third quadrant, right? The solution in the first quadrant is basically going to be the reference angle plus k 180. Okay, so let's get the reference angle. Okay. Right, so I'm going to do this directly into the calculator. Right, so we're going to go shift tan of root 3/3. Okay, and that gives us 30 degrees. Okay, so that's a reference angle of 30 degrees, right? So then therefore, one of our general solutions is going to be x is equals to 30 degrees plus k 180, and k is an element of integers, right? So that's the solution in the first quadrant. Okay. Now what about the solution here in the third quadrant? Well, we just basically have to use the reduction formula there. So it's going to be 180 degrees plus theta, or plus the reference angle. Okay. Right. So on the calculator, you already have the reference angle. Just add 180 degrees to that. That gives you 210. Okay. So that means that the second general solution, or right, x is equals to 210 degrees plus k 180, k in elements of integers. Okay, so that's the two general solutions, right, to this equation. Cos of x minus 30 degrees is equals to 2 sine of x. Okay. Alright, so now for question 6.2, okay, recognize that what they've done is that they're moving from asking you, right, to calculate where two functions are actually equals to each other, right, where they're intersecting, and then they're now asking you more questions, right, on those two functions. Okay, so we now told that the graph, right, of f of x is equals to this first part, right, of the general solution, cos of x minus 30 degrees, and g of x is equals to the second part, right, which is the 2 sine of x, right. And both of these graphs are drawn for you on the Cartesian plane, right, between the interval of minus 180 degrees up until to including 180 degrees, okay. And then we have that a and b, right, are the x-intercepts of f, right. So f, right, if you can see, is basically your cosine function, right. And we can identify that as the cosine function because we know, right, the original shape of the cosine function. Let's just recall it quickly. Okay, we know that the original cosine function basically looks like that. Okay, start off here at 1, right. So you can pull that shape from here. You become very good at identifying these graphs. Right. You can see that there is the shape right over there. Okay, so this is where it used to start at 1, right, but because now this part basically, right, used to be here at the y-axis, right, but because now it's been shifted 30 degrees to the right, right, it's now the y-axis is now this line. Y is equals to 30 degrees. Okay, this is now the imaginary y-axis. Okay, so that's where the cosine function starts. That's basically a y value of 1. Okay, all right. So this means that this is 30 degrees. Okay, right. So now moving on to the questions. Right. Question 6.2.1a. Okay, wants us to write down the coordinates, right, of point A. Point A is over here. Remember that we were told that A is the x-intercept of f, right? So in other words, it's the x-intercept of our cosine function. Let's just remove the sine function over here. All right. So now that we've actually recognized that this line y is equal to 30 degrees is basically our imaginary y-axis, right? We know that this coordinate, right, is going to be exactly this coordinate in the original cosine function, right, just shifted 30 degrees to the right. Okay, so in the original cosine function, this coordinate is 90 degrees, right? So if we take 90 degrees and we shift it 30 degrees to the right, we are basically adding 30 degrees to that. So that's going to shift it, right, to a new location of 120 degrees, right? So that is 120 degrees, right? But they want the coordinate, right? So we're going to write it as 120 degrees, 0. Okay. B, the coordinates of C. Well, we said that the two graphs intersect at C and D. Okay. So C is this point over here. Okay. So if it's a point of intersection, right, then it is basically this general solution, okay, where the graph of f is equals to the graph of g. Okay, so it means that we need to use, right, our general solutions that we determined before, okay, in order to figure out what is the coordinate here at C. Okay, we can obviously see that it has to be a negative, okay, x value, right? So we're going to just figure that out on the calculator, okay? Right, but before we do that, okay, let's just calculate what is the coordinate here at B, right? Just to give us a little bit more of guidance, right? So we know that C is basically going to be the value in between minus 180 degrees and whatever the coordinate here at B is, okay? So that is also not a difficult thing to do, right? B is also a x-intercept of our cosine function, right? And you can see that it is a coordinate on the other side of the y-axis, right? So if we go back to our original cosine function, let me just write here, this is cos of x, right? If we pull it back, right, and we redraw it on the other side as well, okay, I'm just going to stop it there, right? We know that on the other side, okay, this x-intercept would be at minus 90 degrees, right? So if you take the original minus 90 degrees and you shift it 30 degrees to the right, okay, that will put you at negative 60 degrees. So this is negative 60 degrees. So now on our calculator, we're going to find, right, the coordinates of C, right, by recognizing the fact that it has to be an angle between minus 180 degrees and minus 60 degrees. Okay. Right, so I'm going to choose to use the first general solution, right, so 30 degrees plus K, so you know K times 180, okay, and K is an element of integers, right? Obviously we can't use a K value of 0 over here because then we'll get 30 degrees. That's not what we're looking for, okay? Let's just shift the calculator to this side so we can see. Okay, so let's try a K value of negative 1. Okay, so that gives us negative 150, okay, which is actually an angle in between minus 180 and minus 60 degrees, right? So that will be the coordinate at C, okay? But let's just check minus 2. Okay, so that's now an angle much greater than what we're looking for. Let's check positive 1. Also an angle much greater than what we're looking for. Okay, so this is minus 150 degrees. Okay, so C, right, has the coordinates minus 150 degrees as an x value, right, and it's going to have some unknown y value over here. Okay, not difficult to determine. We just need to substitute minus 150 degrees right into one of these functions. Okay, or alternatively to that, okay, you can recognize the fact that the cosine function, right, has only been shifted to the right. It hasn't been moved up or down, right? So this is basically still in the range negative 1, right, to 1. Okay, that maximum there is 1. Okay, so this is negative 150 degrees minus 1. Okay, right, so looking at the range, right, of this cosine function, basically the blue graph, I'm actually noticing now that I've overestimated where this imaginary y-axis is. Okay, so let me explain to you why. Okay, right, so let's go back to the original cosine of x, right? And I'm just going to draw it. Let's draw it between, let's draw it between minus 90 and 90. Okay, so we know that it starts there at 1. Okay, it goes down to 90 this side and down to minus 90 on this side. Okay, and basically where it starts, right, that is a maximum. Okay, so notice that that maximum, right, like for any, if you think of a parabola, right, that is the midpoint between these two coordinates, right? So 90 degrees plus minus 90 divided by 2, that will give you 0 degrees, right, which is that. Okay, so now if we look at this sketch over here, right, what we have a similar condition, right? So if we look there, if you look at B, right, and then you have this apex over there, and then it levels off here at A. Okay, so that's B, that's A. Okay, and we said that B is minus 60 degrees, and A is 120 degrees, right? So if you can see where this is having a maximum, it's actually at this intersection point at D, right? So you can say that's there, that's D, okay? Now, what is the midpoint over here? Minus 60 plus 120 divided by 2, that's actually equals to 30 degrees, okay? So which means that I've actually overestimated where our imaginary y-axis is supposed to be, okay? So if I just fix it quickly, okay, this is not where 30 degrees is. Hope that makes sense, basically. Okay. Just a silly mistake. Right, so now that we've fixed that, we can now move on to 6.2.2. Okay. It now says determine the values of x, right, in the interval minus 180 degrees to 180 degrees, for which, right, A, okay, for which both graphs, right, are increasing. Okay. All right, so we are looking for where both of the graphs, right, are basically increasing in y values as we increase in the x values, right? So as we're moving, right, in this direction, right, we're looking for where both of the graphs are also increasing in y values, okay? Right, so in order for us to answer this, right, let's add a little bit more information to our graph, right? Specifically, let's add a little bit more information to the sine function, right? So this function in purple, okay? All right, so we know that the sine function, right, this is just 2 sine of x, right? So this basically just goes up to a y value of 2. Okay, and it comes from a y value of -2. Okay, sorry. Okay, but it's basically hasn't been shifted, right, in terms of left and right. So this is still the original, right, maximum at 90 degrees and minimum at -90 degrees. Okay. All right, so now let's look as we're moving, right, from left to right. Okay, for this first part, right, you can see that the function g, right, is actually decreasing. Okay, so that's not what we're looking for. We're looking for where it's increasing. Okay, so it's decreasing over here up until we get to 90 degrees, right? The function f is increasing, but we want both of them to be increasing, right? So that starts to happen, okay, when we look from -90 degrees, right, you can see the function g is increasing. Sorry, the function f is increasing, and it's increasing in y values, and that happens until it gets up to this maximum, because after that it's going to start decreasing in y values throughout. Okay. From that x value of -90 degrees, the function g is also increasing in y values. Okay, it carries on increasing right up until we get to 90 degrees. Okay, but the problem is that while it carries on increasing, the function f decreases, right? So we can't take that interval. Okay, after this point of 90 degrees, right, they are both decreasing, right, but we're not looking for both decreasing, we're just looking for both increasing. Okay, so it's just that interval over there. Okay, so this is just going to be x, right, an element of, it's going to be included. Okay, Alright, so now I'm lying, it's not going to be included because if you look at the cosine function, right, not the cosine function, the sine function, right, at negative 90 degrees, it actually has a minimum, right, so at a minimum, remember from calculus, we have a stationary point over there, okay, so we are not increasing or decreasing over here, right, we are actually stationary. Okay, so which means that we can't include that, right? And over there, right, at 30 degrees, right, they are equals to each other, right? So they are neither increasing or decreasing, they are actually equal. So which means that we can't include that point as well. Okay, quite an unusual question that they're asking over here. Right, so this is from an x value of minus 90 degrees up until we get to an x value of 30 degrees. Neither of them included. Okay. B. For B, right, we have to find out where is the f of x plus 10 degrees greater than the g of x plus 10 degrees. Alright, so for question B, right, we can use a little bit of a trick for this, right? And the reason why we can use this little trick is because both of the functions have been moved, right, shifted to the left by 10 degrees, right? So they are going to end up in the same position at the end of the day, okay? So what we can do is that what we can say is that we can find where is f of x, right, greater than g of x, okay? Then once we found that interval, just shift that interval to the left by 10 degrees, and then that's going to therefore give us where is f of x plus 10 degrees greater than g of x plus 10 degrees. Okay, so where is f of x greater than g of x, right? In other words, where is the cosine function, which is in blue, right, above the sine function, which is in purple. Okay, well, hopefully you can see that that's going to happen in this region over here. Okay, between minus 150 degrees and 30 degrees. Okay, we have the function f, right, f, the blue graph, right, being above the function g, okay, the purple graph, right, for this entire interval, okay, and that doesn't happen anywhere else, okay. If you look at the other side, right, g is actually above f, and also on the other side, g is above f, okay. So this interval, okay, is in between. Now let's think about, is it included or not included? Well, there's no equal sign there, so it's not included, right? So for this first condition, this happens when, okay, x is in between minus 150 degrees, right, and 30 degrees, okay. So then therefore, right, if we take this interval and we just subtract 10 degrees from both ends, right, minus 150 degrees minus 10 degrees is going to be minus 160, and 30 degrees minus 10 degrees is going to be 20 degrees. Okay, and that then brings us to the end of question number 6, right, from May-June 2019. Okay.